Good morning, everybody. Okay, so where we're at now is we just finished our atoms, and how that is for us is that's sort of like our alphabet, and so we want to take the next step. So now that you have your periodic table and you got it all marked up and all this other kind of stuff, these are the letters of your alphabet, and now we're going to take these letters and we're going to make words. And so this unit is all going to be about making formulas. Okay, and so you guys have a couple packets with these kind of things in as well. I'll show you what worksheets I want to do as we go through this. Um, but I just want to understand what we're going through here. So basically, we have our letters. We're going to make words in the next unit, and then our last unit before we get out of here is we're going to make sentences and make actual reactions happen. Okay. So what we're going to talk about today is how these things actually stick together, and that's really what this week is about. So on this is Monday, we're going to talk about ionic bonding today, and then on Wednesday we're going to talk about covalent bonding, and on Friday we're going to talk about something called polyatomic ions, which sort of combine both things together. And then starting next week, we'll really get into the blood and guts of making the words and putting them together. If we were in school, we would do all this in a day or two, but we got to spread it out a little bit just because it's a little harder for us to do it virtually as we go through this. So here's what we're looking at today. All right, as we go through this today, I'm trying to get this on the screen for you guys. Today we're going to talk about ionic bonding. And ionic bonding is a transfer of electrons from a metal to a non-metal. So basically what's going to happen is if you look at your periodic table, you have your metals on the left-hand side, your non-metals on the right-hand side. When those two things want to react to create their new compound, that's what we're trying to create here with this new thing, we want to make sure that we're doing it the right way. Okay. And trying to make sure everybody is happy. Remember that last column, that noble gas column, they're already stable, happy, and content. So nothing's going to be involved with those as well. But the rest of them are going to, in this case, transfer electrons, means we're actually going to give them up. So we talked about electronegativity in the last unit, about the ability to go steal an electron from something else. Okay, metals have that high electronegativity. They're going to be on the they're going to just try to give up their stuff. The non-metals, I'm sorry, have the very high electronegativity. They're going to go steal and be on the hunt and go get these kind of things. So how we show this is we do something called a Lewis dot diagram. Now, for Lewis dot diagram, it's really, really simple. Okay, you simply are going to show the valence electrons only. So if I'm going to draw lithium, I'm going to put Li with a dot. That's a Lewis dot diagram. If I'm going to show fluorine, I'm going to put an F because that's a symbol for fluorine. And if you look above, you should have 7V written above the halogen family. Again, just look at your chart. Go back to the videos if we don't know that. And now that has a 7V above it. So it's 1, 2, 3, 4, 5, 6, 7. And that's how we write our valence electrons. Those are Lewis dot diagrams. Now, what we're talking about here with ionic bonding is these things want to make themselves happy. So if you look at the alkali metals, lithium, sodium, potassium, all those on this side of your periodic table right here, they all want to give up one electron to be stable, happy, and content. Just one. Fluorine's row wants to, the halogens want to take one in. So what's going to happen is these two things are going to come close together. Fluorine and lithium are going to come close together. This is a metal right here because it's on the left side of my periodic table. This is a non-metal because it's on the right. This electron right here, fluorine's going to come over and it's going to steal it. It's going to rip it over to itself. And it's going to put itself right there. Okay. Now, what does that do? That makes lithium happy because now lithium only has its full shell. And we got to go back to what we did before. This is what lithium would be 2 in the first, 1 in the second. We only showed the 1. So we got rid of that. I know I got dry erase markers a little easier for me than for you guys. So now lithium's happy. Okay. Lithium's happy as a +1 charge. Fluorine takes 1 in. And now look, it's got its 8. It's fulfilled its octet rule. And so fluorine has a -1 charge. This one is now happy. This one is now happy. And this positive and negative attraction creates what's called an ionic bond. These two attractive forces keep those ions close together. and we created a new compound. Okay, we created a new compound. We show these things how it is. Now, how we write a formula for this is we just simply tell you how many of each one we have to make each other happy. So this one would just be LIF. We don't write, I mean, we can have one and one. We just don't write ones because we're that lazy. Okay, but that's all ionic bonding is. The metals are going to give up and transfer electrons from metals to nonmetals. Nonmetals, they're going to go take it, steal it, rip it away. But everything has to be happy and everything has to be stable, okay, as we go through this. All right, and so, sorry, there's that top line there. So let's look at another combination. Let's say we're going to try to combine beryllium now with fluorine. Beryllium is an alkaline earth metal, okay? It's in this second family right here, okay? And so how many dots is it going to have? That's right, it's going to have two. All right, again, I always feel like Dora, I'm talking to nobody here. All right, fluorine still has its 7. There's its 7, okay, for ionic bonding. Now, fluorine is going to react with beryllium. It's going to pull the beryllium towards itself. And this fluorine is perfectly happy. But this beryllium's not happy yet. It's just not. All right, because it wants to give up its 2 to be stable. We got to fulfill that octet rule. So another fluorine is going to come around, and it's going to pull that one toward itself, and it can do this as many times as necessary. Okay, now this beryllium is Be plus 2 because it gave up 2. Each one of these is minus 1, and now everything's happy. And what happens is this Be plus 2, this F minus 1, and F minus 1 are going to be attracted to each other by positive and negative attraction, and everything's going to be stable, happy, and content. There's my new compound. So how many of these do I have? I have 1 Be, and I have 2 of the fluorines, and that is our compound, BeF2. Okay? And so what's going to happen is, the idea behind this is that these things are going to come together to make all each other happy. Remember, this one wasn't happy, and these weren't happy, but now, in their ion form, they're all happy, stable, and content. Okay? We make a whole new element along the way. What if something else happened? What if we need something on the other side? Okay? So let's say we're going to have calcium created with oxygen. So you look in calcium's in the alkaline earth metals, and so it gets 2 valence electrons. We still use our Lewis dot diagrams. And oxygen has 6. 2, 3, 4, 5, 6. There's oxygen. Okay. Oxygen is going to come near calcium. Calcium's on a metal because on the left-hand side. Remember, metals are on the left. Non-metals are on the right. A lot of you guys had your line drawn perfectly on that part. So this one is going to give it up here. And it's going to give it up here. And now everything's happy. We've given up, metals give up all the ones they have in their Lewis dot diagrams, and oxygen want to get up to 8. All right, we're going to say octet rule. So what happens is calcium gives up its 2, so it's a plus 2. Oxygen takes in its 2, so it's a minus 2, and they stuck together. Now everything's happy. Okay, and we have one of these and one of these. And so it's just CaO. Okay, and that's all ionic bonding is. A transfer of the electrons from the metal to the non-metal. So I need to go in your packets. Okay, you're gonna go look, and I know this is gonna seem weird, you're gonna look for this packet right here. All right, it was one of the first ones we did. All right, but in that packet, you have a worksheet that looks like this: bonding and chemical formulas. Okay, so all I want you to do is this. I want you to do the charge of the ion, and so you should have that written above in the periodic table. You should find that atom and find what charges we make on your periodic table. These are going to be your metals right here, and then these are going to be your non-metals right here, and find the ions here. And what I want you to do for this, okay, and I'll do the first one with you just so you guys can see what I want you to do here, is I want you to fill in this sheet, but I also want you to do a drawing for each one of these as well. So you're going to take a picture of this, and then you're going to take a picture of your drawing. So here's what I want, okay? So here's aluminum. It's got its 3 valence electrons. So this is what your drawing would look like. And here's chlorine with its 7. All right. So right now I would have this one would form a plus 3. Okay, I just write a +3 in there because it would give up these 3 electrons to be stable, and that's what you have on your chart. And this one would be -1 because only use -1. So what happens here is this one pulls it into here, and this one makes -1. Okay, so I have my +3 and I have my -1. But see, this doesn't work because chlorine is full, but aluminum's not. So we need another chlorine. And so we pull that one in, and we need another chlorine. Pull that one in, and now everything's stable. Aluminum has formed its +3. Chlorine has formed its -1, but it took 3 of them to balance it all out. And so our formula ends up being AlCl3 because we have 1 aluminum and 3 chlorines. Okay, and so that would be AlCl3. And I would write AlCl3 in there. So I want you to do this for all these little things right here. And I want you to do an atom drawing for each one of these things as well. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've already done one of them. You got 9 more of these to do. That's going to be your assignment. And I'll write it all and type it out of your assignment. But again, I want this filled out and take a picture of this. And I want your 10 drawings like this on a piece of paper or 1 or 2 pieces of paper, whatever, and take a picture of that. And then submit that for your assignment for today. Okay? All right, that's it. Have a great day, everybody. Be good. I will see you later. Keep safe, keep healthy. If you have any questions, email me like always.